Hello, students. I'm Professor Benavides, and let's talk about dictionaries. Now, this is chapter 6 out of your book, and I'm going to cut it up in 3 parts because it needs to be covered in a very thorough kind of way. So, part 1 is going to be about how to create a simple dictionary and how to work with dictionaries. So, let me just give you just an overview of the entire chapter. As well, since we're starting at the beginning. In this chapter, we're going to learn how to use Python's dictionaries, which allow you to connect pieces of related information. You're going to learn how to access the information once it's in a dictionary and how to modify that information. Because dictionaries can store almost limitless amounts of information, you'll learn how to loop through the data in a dictionary. Additionally, you'll learn to nest dictionaries inside of lists, lists inside of dictionaries, and even dictionaries inside of dictionaries. So that's pretty much the 3 parts that we're gonna go ahead and cover. The first part is we'll study what a dictionary is and how to access it and modify it. And then in part 2, we'll talk about looping, and then in part 3, we'll talk about nesting. So, what can I do with dictionaries? It's a great way to model a variety of real-world objects more accurately. So that's what we're going to go ahead and learn. You'll be able to store any 2 kinds of information that can be matched up. So let's go over a simple dictionary, and that's what I have right in front of you right now, a simple dictionary. Let's take a quick look at it. So a simple dictionary stores information, in this particular one, about a particular alien. The dictionary alien _0 stores the alien's color and point value. The last the last 2 lines shows how we can access and display that information. So here we see on line 4, let me increase the size of this. On line 4, we define our dictionary. So to define a dictionary, we start with the name of the dictionary, an equal sign, and we define the dictionary with an opening and closing curly brackets. And then we have a key value pairs. In this case, we have color that gets green and points that gets 5. These key value pairs are separated by a comma, and we can have as many of them as we want. So as far as accessing and displaying, to access the value of color, you would specify the name of the dictionary and then in square brackets, the name of the key. We're going to then pass that as an argument to the print function to allow us to display that information. So let me go ahead and run this with the Control B, and we see that line 7 gives us green, and line 8 gives us 5, which is as defined on line 4. So a dictionary in Python is a collection of key value pairs. Each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can use any object that you can create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces, I call them curly brackets, with a series of key value pairs inside the braces. So what is a key value pair? A key value pair is a series of values associated with each other. So when you provide a key, Python returns the value associated with that key. Every key is connected to its value by a colon. So like here in this example, see there how we have the colon? Here's the key, and here's the value. Here's another key value, and it's separated by a comma. All right, so this is the definition of the dictionary in line 4, and we access it and display it on lines 7 and 8. So continuing to define how you create one, every key is connected to a value by a colon. And individual key value pairs are separated by commas. you can store as many key value pairs as you want. So to reiterate, this is the dictionary. We're going to go ahead and use these brackets to define it. The key value pairs are going to be separated by a comma. So the key designates or points to its value with the colon, right? So every key is connected to its value by a colon. Every key is connected to its value by a colon. And these key value pairs are separated by a comma. I know I repeated that a lot of times. It's important to get it in your head. So how do we access the values in a dictionary? Let's go over this in another example here. In this example here, next example, we're going to define the dictionary on line 5, which is the same one we had before. And then we're going to pull, a value associated with the key points from the dictionary. Many times people call them dicts, D-I-C-Ticks, D-I-C-T. So in this particular case on line 8, I'm going to get the value associated with this key and assign it to a variable called new points. And then I'm simply going to go ahead and print that. Let me go ahead and run this. So you just earned 5 points. So to get the value associated with key, you give the name of the dictionary and place the key inside a set of square brackets. So here it is. This is what we're learning in this one here. Before we learned how to define a dictionary, now we're learning how to pull a value associated with a key. So to pull a value associated with a key, we have to specify the key in brackets. In this case, it's a string called points. All right. Let's go ahead and go over the next example here. In this example, we're going to talk about adding new key value pairs. So on line 4, I define my dictionary, and then on line 5, I simply print it. Then when you do that on line 5, it gives you the square brackets. Then on line 7 and 8, I add a new key value pair and another key value pair, and then I print it again so we can compare the original key value pair with the modified one. And this is an example of the idea that dictionaries are dynamic structures. You can add new key value pairs to a dictionary at any time. This is an example of it. And as of Python 3.7, dictionaries retain the order in which they were defined. So let me go ahead and run this. So here we see the original dictionary followed by the updated dictionary for the alien, which shows first we had the color and the points key. Now we have the X and Y coordinates for the alien, so that you can imagine we're going to make a game and we're going to have to designate the location of the alien image on the screen, which is typically 0, 0 is typically upper left-hand corner of the screen. So this would be setting X and Y coordinates to 0, 25. Okay. Let's talk about starting with an empty dictionary and why you would want to do that, sometimes. So let's take a look at the next example on here. So on line 4, we go ahead and define an empty dictionary. And then on 7 and 8, what we do is we add key value pairs. Pretty much what we did before, but before it was a dictionary that already had something to it, and we were just adding. We had it before. We had a dictionary that we had defined, and we just adding more key value pairs. In this case, the dictionary is completely empty, and then we just print it out. Let me just go ahead and run that so that you can see that. So why create an empty dictionary? It's sometimes convenient or even necessary to start with an empty dictionary and then add each new item to it. To start filling an empty dictionary, define the dictionary with an empty set of braces, and then add each key value pair on its own line. So that's what we did here on line 4. Here is the definition of the empty dictionary. And then I add key value pairs on separate lines, and then I went ahead and printed the dictionary on line 11. Okay, So why use empty dictionaries? Typically, you use empty dictionaries when storing user-supplied data in a dictionary, or when you write code that generates a large number of key value pairs automatically. So in other words, let's say you're prompting the user for information. You may not have anything already stored in it, so you can start off with an empty dictionary and then be adding to it as you prompt. So let's go ahead and talk about modifying values in a dictionary. So how can you modify values in a dictionary? To modify a value in a dictionary, you give the name of the dictionary with the key in square brackets, and then the new value that you want to associate with that key. Let's go ahead and run this, and we'll take a look at this. So line 4, I define my dictionary, simple dictionary with just one key value pair, and I just show it to the screen. The alien's green. So how do you change the value associated with color? So it's an assignment statement, isn't it? Line 8, I assign yellow. Okay, so you have to say alien, and you use square brackets, not curly brackets. And then you put the equal sign and you assign yellow to it. And then I just go ahead and print out that same. I print out line 5 again. In fact, you just copy and paste that again. Save yourself from having to type it in again. So let's look at a more interesting example of the same idea. It's a little bit longer, so I'm going to go ahead and reduce the size of the font so I can see as much of this as possible on here. So basically, let's go ahead and take a quick look at this. I define my dictionary on line 4, print out the original dictionary, print the original value, for X. Oh, I'm gonna have to like uncomment a few things here to experience this fully. All right, so let's go over, there's some ideas that need to be covered here. So on line 10, basically what I gotta do is I gotta uncomment line 10 here so that we can see what's gonna be going on. Let me just raise this up a little bit, and we'll come back to it as we go along. So let's back up a little bit and see line 4, I define my dictionary, and I'm assigning 0 to X and 25 to the Y coordinates, right? And then I'm setting speed to medium, okay? Those are my key value pairs. Remember, the key value pairs are separated by comma, and the key is associated with its value by means of a colon. So in this particular case, I want to go ahead and just show the value of the X underscore position key. All right, let me just go ahead and run it the way it is. See how it's got the original position is 0, and then the new position is going to be 2. We'll get there. But for right now, I want to go ahead. Well, maybe I'll come back to that. I'll uncomment that later. Let's just run it like this here so that you can see. Okay, let's go through this else if. elif chain. And in this elif chain, I'm going to go ahead and say if speed is equal to slow, then I'm going to set the X underscore increment to 1. It was originally set to 0, right? Now I'm setting speed to medium. So the next thing I go and I say here, if alien underscore 0, the speed is equal to, notice how this is 2 equal signs, guys, not 1 equal sign. Got to remember that. If it's equal to medium, then I'm going to go ahead and set 2 to X underscore increment. And then, of course, this could have been, I guess, another elif if speed was fast. But we'll just say else, and this must be a fast alien, so I'm setting X underscore increment to 3. So then all I do here then is on line 23 is I'll have this incrementer where the new position is the old position plus the increment. So here is the old position, here is the increment. So we're setting up the speed for the alien, right? So if I'm saying that the speed is medium, then we go through this elif chain and I test for speed being medium. So I'm going to set X underscore increment to 2. So if it was originally 0, it was. Remember, see how I set it to originally to 0. I'm going to go ahead and add 2 to it so that the new value is 2. So 0 plus 2 is 2. And then I print it out. And that's why I get original position 0 and new position 2. Okay, fine. Now we can get to this thing that I wanted to uncomment. I wanted to uncomment that I think maybe prematurely. So what I'm going to do here is I know I have set speed to medium in the definition, but let's say that I go ahead and set speed to fast. So let's go ahead and run this. And as you can see, new position is set to 3. So the original position is 0, right? I go through my elif chain and the else fires because it's not, speed is not slow, speed is not medium. So if the else catches and I assign 3 to increment. So 0 plus 3 means that the new position is 3, right? So that's how we get that printed out down there in the bottom, okay? So now let's talk about removing key value pairs. And I want to go ahead and, all right, so to remove this, we're talking about the delete statement. So how do you remove key value pairs? So when you no longer need a piece of information that's stored in a dictionary, you can use the del statement to completely remove a key value pair. All del needs is the name of the dictionary and the key that you want to remove. Be aware that the deleted key value pair is removed permanently. So let's just take a look at what we got. I got the definition of my dictionary there on line 4. So key value, I got color and points, and I print it. Fine, let me just go ahead and print it right now, or run it. So then I'm going to go ahead. So here we have our original dictionary on the first line of output. Then I'm going to go ahead and delete points. So when I delete the key points, it gets rid of points and the value 5. So when I print the dictionary again, I'm going to go ahead and just get color, being set to green, right? So that's the del statement. Let's go ahead and cover favorite languages. This is a pretty neat one here. This is a dictionary of similar objects, all right? So let's go ahead and go over this. So the idea here is that the previous example involves storing different kinds of information about one object, the alien in the game. You can also use a dictionary to store one kind of information about many objects. A good practice is to use a comma after the last key value pair as well. So you're ready to go ahead and add a new key value pair on the next line. So that's what we have here on line 4. I've got my dictionary, and as soon as I type in my opening curly bracket, I press enter and I put in my key value, key value, key value, key value, and then I put in this last trailing comma, which when we were using the long version of this, we didn't do before. And then we close it by putting the closing curly bracket to be aligned to the indentation here. Okay, so here we're going to go ahead, let me go ahead and run this. Here we're going to go ahead and on line 12, we're going to say language gets favorite underscore language Sarah dot title. Now what does that mean? That means that we're going to the dictionary and we're looking up Sarah's favorite dictionary, which is C. So in this case, we say Sarah's favorite language is, and we put in the little placeholder the variable language. So remember on line 12, we're accessing the value C and assigning that to a variable called language, and then we're putting language in a placeholder in a formatted string on line 15. Okay, so that's how we can use a dictionary of similar objects. Now we're going to get to something I think pretty cool. I'm pretty impressed with this particular feature. You know, you're a real geek when you say something coding structures are cool, you know. So let's talk about using get to access values. So at line 4, I've got my dictionary defined. Okay, well, let's just give me a little bit of background before I get going on this. Using keys and square brackets to retrieve the value you're interested in from a dictionary might cause one potential problem. If the key you ask for doesn't exist, you will get an error. The get method requires a key as the first argument. As a second optional argument, you can pass the value to be returned if the key does not exist. That's the cool part, okay? If you leave out the second argument in the call to the get method and the key doesn't exist, Python will return the value none. Now, the special value none means no value exists. This is not an error. It's a special value meant to indicate the absence of a value. Okay, so let me go ahead and just run this. And I kind of like modified the original code a little bit, but line 4, we define our dictionary. On line 7, I went ahead and backed up a little bit and I said, let's just go ahead and let's prove, or let's say that if the key exists, well, what do you get? Well, you get the corresponding value. We learned that before. If we specify the key, what are we going to get? Green. So line 7 will give us green. And I'm going to come, well, okay, let's go to line 10. Notice how I've got to uncomment this. If the key you asked for does not exist, then you're going to end up getting the key error exception. So let me go ahead and uncomment this. And I'm going to go ahead and run it, and we're going to look at the traceback. So Control B, and look down here below, and we can see, yes, it is a key error. See traceback. This is happening on line 10. I can see all of that, and just more stuff for people to. Now, the way you get rid of this is you got to click on the X, but I can't see the little X, so I'm going to have to do a Control minus sign until I see the little X, and then close it. See how I did that? Control plus sign to make it a little bit bigger. I'm going to comment that out again because I don't want to be crashing all the time, you know. So then, now we learn about get, the get method, right? So on line 13, I say get color. So when we do that, let me just go ahead and run that. When we do that, we get the same thing as we did before when we just access access the value by specifying the key on line 7. We're getting the same thing again. The benefit of using get is to use it with 2 arguments. Only the first argument is required. But when you use the first argument, you simply get the same effect as before. The best part is having the second optional argument. Here in this case, I'm saying alien underscore 0.get points is the key. And if it doesn't exist, which it doesn't, look at this, I got color and I got speed, I don't got points. So if I don't have points as a key, it's going to say no point value assigned. And I assign that to a variable, and then I print it. That's why you see here down below, no point value assigned. And now, if I try to access a key that does not exist, okay, and I don't have a optional second argument, it's going to return none. So none is then assigned to point value, a variable that I create, and I simply print it. Cool stuff, huh? All right, so let's just go ahead and look at the last parts of this section, or the first part of this chapter. Let's look at 6.1. Try it yourself, 6.1. So in this particular little program here, it's called Person. It says use a dictionary to store information about a person that you know. Store their first name, last name, age, and city in which they live. You should have keys such as first name, last name, age, and city. Print each piece of information stored in your dictionary. Pretty easy stuff, because you know these try it yourselves are meant as ways of reviewing the chapter. So let me go ahead and run this. So what does it print out? Yeah, I took this just right off the solutions off the website, right? It prints the name of your author, Eric Mathis, 43, and he lives in Sitka. Now I looked that up. You know, I think I may have told you before, he lives in Alaska, and I just wanted to look up that city. It's like a little over 8,000 people, and it's beautiful. I mean, you've seen the pictures of this. Oh my God, so clean, so pretty. And you know what? When I looked up the history on it, it used to be a Russian city. You know, I mean, I think most of us learned that Alaska was purchased from Russia. So you still see some architecture, you know, churches and names of cities and stuff like that. So I think this is really interesting. But anyway, on line 3, notice we've got that new kind of syntax where when we're defining the dictionary, instead of just going left or right, after the opening curly bracket, press enter, and on that first indent, put every key value on a separate line. And on the last one, end it with a comma, because it's considered a good practice. And then the closing curly bracket, I know he calls them braces, you just go ahead and align it to the indentation. So on line 10, 11, 12, and 13, all we're doing here is accessing and printing the values associated with the keys for first name, last name, age, and city. So what happens here is I access the dictionary by specifying the name of the dictionary, square braces, and then the name of the key that will give me Eric. That is then passed as an argument to the print function. So even though it says, access and display, so the access part is here, and then the display is coming from the print part of this. Let's go ahead and look at the next example here. All right, so in this next example, it's a little bit longer, not a whole lot longer, but a little bit longer. This is 6.2. It says, use a dictionary to store people's favorite numbers. Think of 5 names and use them as keys in your dictionary. Think of a favorite number for each person and store each as a value in your dictionary. Print each person's name and their favorite number. For even more fun, pull a few friends and get some actual data for your program. And that's really what he wants us to do. It's just a matter of, do you have time for that or not? You could just make it up, you know? So in this particular case, using the same format, I create a dictionary, Mandy's favorite number is 42, etc. on here. And then what I do is I access the value by using the square brackets, and I put it into a variable. Now, do I need to do it this way? No, I could put this little section in here, right inside of here, inside of the placeholder. But I like the idea of partitioning that task, putting it into a variable, and then using the variable as a placeholder in this formatted string. It's very nice, clean programming. You don't need comments when code is so easy to read and understand like this. So go ahead and run this. And as you can see, we've got Mandy's favorite number is 42. And then the rest of them. All right, so let's go ahead and go on to our last example before we close this section out. Go ahead and run it so you won't get confused on here. This last one's called glossary. It says a Python dictionary can be used to model an actual dictionary. However, to avoid confusion, let's call it glossary. So no, that confuses me more, right? No, just so think of 5 programming words that you learned about in the previous chapters and use these words as keys in your glossary and store their meaning as values. Print each word and its meaning as neatly formatted output. You may print the word followed by a colon and then its meaning, or print the word on one line and then print its meaning indented to the second. So he's giving us a little bit of options on here. Use the new character to insert a blank line between each word meaning pair and your output. So let's go ahead and take a look at the what we got here. On line 1, I've got my dictionary, right? And so, you know, the key is string, and the definition of string is a series of characters. The key is comment, and the definition of comment is a note in a program that the Python interpreter ignores. List, it's a collection of items in a particular order. Loop, work through a collection of items one at a time. And a dictionary is a collection of key value pairs. Great summary of what we've covered so far. So what do I do down here is I assign string to word, and then I go ahead and say word, which would be string capitalized, right? Or for capitalize the first character. I put in the colon, and then I access the value for word, which is a series of characters. So that's what we get here. String, and then we get the value, which is a series of characters. And we do the same thing over and over and over. Now, this escape code of the \n is what gives us this blank line here. Okay, I'm not sure why he used it on the first line, but that's okay. It does make the output look a little nicer, pushing it down one line anyway. So I don't got a problem, you know, with that on here. So that, my friends, is the end of part 1, simple dictionary and working with dictionaries. I think probably my favorite topic was this get method. Where was that? That was definitely, you know, I was pretty impressed with that on there. But other than that, well, thank you very much, and look forward to seeing you in the or talking with you in the next recording.